been really honored today to talk about, in my opinion at least, the most ambitious project within ARC CBBC program. It is about activation of methane and conversion of this molecule to mainly hydrogen, ethylene, benzene, and carbon materials. We probably all know there are immense amounts of methane on our planet. The reserves of methane are truly, truly impressive. In fact, it is by far the most abundant organic molecule on our planet. Many people would probably frown. They would think, look, 21st century, we are talking about methane. It's a fossil fuel, right? In fact, it's not really true, because in the future, methane will remain a very important molecule. First of all, we, of course, know about shale gas, class rates. We do burn a lot of methane. One thing we should know about this simple but tricky molecule is that methane is way more greenhouse than CO2. So we actually aim to prevent methane emissions at all costs. And for this purpose, at many refineries, methane is just simply being burned. What is important about that, though, that in the future, methane will be an important molecule as a product of our waste conversion. So we will be able to convert organic wastes into methane. And in order to make use of the situation, we have to really develop ways to chemically process this molecule. What we do now? What we do now is something a little bit extreme, because we take methane, we react it with either oxygen or water, and we produce hydrogen out of this reaction. So you can see on this indirect route, we either produce hydrogen, which we can use in the future for production of ammonia or other things, but also, materially speaking, we do lose a lot of carbon atoms to produce those carbon monoxide and carbon dioxide that are not really useful. So what are the alternatives? We can either directly oxidize methane to produce ethylene, methanol, or, for instance, chloromethane. But the disadvantage of these chemical routes, it has been already for several decades, is that the more stable products of methane oxidative conversion are carbon dioxide, once again, leading to losing of these carbon atoms. An alternative here is non-oxidative conversion of methane, where we can make such important molecules as aromatics, benzene, ethylene. We all know polyethylene is the most produced organic molecule in the world, and functional carbon materials. And as a very, very important byproduct, we have hydrogen gas. Of course, if it was so easy, it would have been done already many years ago. As this graph here demonstrates, in order to convert methane to useful products in a non-oxidative manner, you need very high temperature. So in fact, to achieve methane conversion of, let's say, 20% to such a molecule as benzene, you need 800 degrees centigrade. Fortunately, our modern chemical industry is not very well designed for that. It's out of comfort zone of modern chemical industry. And that is exactly what our ARC CBBC flagship project is about. So this project is about developing, synthesizing catalysts that are capable to selectively convert methane to either important organic molecules such as benzene and ethylene, or functional carbon materials. And not only we have to develop catalysts, we have to develop a whole process. We have to develop reactors that would be suitable for performing this reaction at extreme temperatures. That is the main challenge of ARC CBBC. You see the design of our flagship project. So there are several groups from both universities of Utrecht and Technical University of Eindhoven. Researchers from Shell and BASF work together in order to develop a multi-scale approach towards development of the catalysts and development of the catalyst technology. So, and in my opinion, the main advantage of ARC CBBC is a diverse team of talented researchers. We have been talking a lot about professors and assistant professors today, but people who actually do the work in science are PhD students. Some of them you have seen today, and I've been truly been blessed to work with these people, and they make the thing that I've just discussed possible. So to finalize, I want to thank all the PhD students, all the people involved in this nice project. I've been truly been blessed to work with these people, and it's my great honor to talk about this. Please stay tuned. Really, future news are coming from this flagship project. Thank you.